Hello student, good morning. Today's topic is energy stored in capacitor, and in this topic we understood how a capacitor stored energy with storing charge. Okay, student, we know a capacitor is stored charge and hence stored energy. We also learned in the previous lectures, when we giving the charge to plate A, then due to polarization, a plate which is kept near to the plate A is charged negatively when it urged. Okay, so as we giving the charge to plate A, the charge increase on the second plate as negative. So storage capacity, charge storing capacity of plate A will increase due to this particular arrangement. Hence, the capacity of storing charge by the capacitor will increase, and we call as increase in charge between the two plates, it also stored energy. So now we want to understood about what is the value of charge stored in a capacitor. So consider a capacitor having charge storing capacity Q when potential difference between the plate is V, which is given by C is equal to Q upon V. Equation first. Now when we add the more charges between the capacitor or on the plate A, then there will be some work done by the external force. Therefore, work done on adding more charge dq in capacitor is dw is equal to v into dq. Now on putting work done v into dq. Okay, now on putting the value of v from equation first, that is v is equal to q upon c. Okay, we get dw is equal to q upon c dq. This is equation second. Now for calculating the total work done to storing the maximum charge in the capacitor, we integrate the equation second. Total work done is given by integration of dW is equal to integration of QC dQ. Okay, now this dW is become total work done, and 1 upon C is a constant, and the value of Q square upon 2. This is now the total work done to storing the Q charge in the capacitor is Q upon 2, Q square upon 2C. By using the value of Q square from equation first. Okay, first this work done is stored as stored in the capacitor in the form of potential energy, that is U is equal to Q square upon 2C. This is the value of energy stored in capacitor, and this is how a capacitor stored energy. Now student, we have C is equal to Q upon V. Now we apply the value Q is CV in the energy, that is U is equal to CV square upon 2C. It will become C square upon V square upon 2C. This C cancel the square and we get the result energy is equal to half CV square. This is the standard form of energy stored in the capacitor. We can also use the value in place of V. We can use this when we place in place of C, then the other form is U is equal to, in the same equation, Q square upon 2. In place of 2 C we can use Q upon V. Now student, this Q cancel the square and we get the relation is 1 upon 2 CV. This is also a most important form of this energy stored in capacitor. So student, just copy this. Okay, student. Now we have the form of the storing energy as the energy stored in capacitor is, first is q square upon 2c, second is half cv square, and third one is half qv. This is the forms of energy stored in capacitor. Now we go for the energy density. Okay, student. Energy density of capacitor. Okay. Energy density of a capacitor is defined as energy stored in capacitor per unit volume. Volume of capacitor. Okay, student. Now energy density UD is equal to energy stored upon volume. That is energy stored in capacitor, any of this form. That is half CV upon volume. Okay, CV square upon volume. Now student, we have, now I am writing this value UD, energy density is half CV square upon वॉल्यूम. ओके, वॉल्यूम को हमने थोड़ा सा चेंज भी बनाया है ताकि इजीली अंडरस्टूड हो जाए. नाउ वी हैव C is equal to A epsilon naught upon D. Clear, student? Okay. Therefore, on putting this value here, we get UD is equal to half A epsilon naught V square upon d into v. Okay, now student, we have A is area epsilon naught v square upon d into, we can write this A into d. Okay student, now this is cancel area to area, and we have energy density is equal to half epsilon naught v square upon d square. 1 minute. Okay student, this we get energy density is half epsilon naught v square upon d square, and we know that electric field is given by potential difference upon the distance, that is E is equal to V upon D. On putting in place of V square upon D square, E we get energy density is half epsilon E square. Copy this. Okay student, next topic is redistribution of charge or common potential. It is a very most important topic. Now we understood how the capacitor get their common potential. Let two capacitors having charge capacity Q1 and Q2 are connected across each other as in parallel combination or in series combination. Okay, let the capacity of first capacitor is C1 and second is C2, having their potential charge capacity Q2 and Q1, and hence potential V1 and V2. We want to get the common potential after the redistribution of charge. Okay, now consider two capacitors of capacitance C1 and C2 having charge capacity charge Q1 and Q2 with initial potential difference V1 and V2 respectively. Let when charge starts flow from higher potential to, let charge starts flow from higher potential to lower potential till both get common potential. Initially C1 and C2 have charge Q1 is equal to C1 V1 and Q2 is equal to C2 V2. इनिशियली उनकी कैपेसिटी अलग है, उनके चार्ज कैपेसिटेंस अलग अलग हैं. सो देयर charges are Q1 is C1 V2 and Q2 is C2 V2. Now when they get common potential, therefore common potential V is equal to total charge upon total capacitance. Total capacitance. We have Q1 plus Q2 upon C1 plus C2. Therefore इसको स्टूडेंट हम इस तरह से भी दिखा सकते हैं डेल V करके. So the common potential del V is equal to the value of C1 is C1 V1 and value of Q2 is C2 V2 upon C1 plus C2. This is the common potential. Therefore charges of the capacitors after redistribution of charge, after getting common potential, is Q1 is equal to C1 V and Q2 is equal to C2 V. This is the value of the charges after redistribution and this is the common potential. Copy this. Okay student, next topic we take the energy loss in transferring of charge. Energy loss of capacitor in transferring charge. It is also very most important topic. Okay student, two capacitors are connecting, which having the capacity C1 and C2. We learn when two capacitors are connected each other, then transfer of charge takes place between them from higher potential to lower potential. Let V2 is higher than V1. Similarly, we taken in the redistribution, V2 is higher than V1. This transfer going till they get common potential. Okay, in this process some energy is lost by doing work to get common potential. Okay, student, total energy before combination is U initial is equal to energy of capacitor 1 half C1 V1 square plus half capacitor 2 is C2 V2 square. Okay, this is equation first. Now, and total energy after combination. That is after. Okay. It is common potential, that is C1 plus C2, and the common potential is V square. And student, we have the value of common potential. Common potential del V or V is equal to Q1 C1 plus Q2 C2 upon C1 plus C2. Okay. Now on putting this value here, half C1 plus C2, in place of V we can put C1 Q1 C1 plus Q2 C2 upon C1 plus C2 square. On solving this, we get half C1 plus C2 plus Q1 square C1 square plus Q2 square C2 square plus 2 Q1 Q2 C1 C2 upon C1 plus C2 whole square. Now this square is cancelled by the numerator. We get energy after combination is half C1 square Q1 square plus C2 square Q2 square plus 2 Q1 Q2 C1 C2 upon C1 plus C2. This is equation second. So student, first copy to this equation second. One minute. The value is, in place of Q we written na C1 V1 C2 V2. So V1 V2 V1 V2 V1 V2. Now this is also V1 V2 V1 V2. Just copy it till this point. Okay student, now loss in energy. Loss in energy in combination. Is given by del U is equal to initial energy to final energy. Initial energy to energy after combination. That is half C1 V1 square half C2 V2 square and minus half C1 V1 square C2 V2 square plus 2Q1 2C1 V1 V2 C1 C2 upon C1 plus C2. Okay, student. Now, on taking LCM, two C1 plus C2, C1 V1 square C1 plus C2 plus C2 V2 square C1 plus C2 and minus C1 V1 square C2 V2 square plus 2 C1 C2 V1 V2. Okay, by multiplying we get C1 square V1 square plus C1 C2 V1 square plus C1 C2 V2 square plus C2 square V2 square and minus C1 V1 square C2 V2 square plus 2 C1 C2 V1 V2 and in denominator C1 plus C2. Okay, student. Now here C1 square V1 square positive and C1 square V1 square negative is cancelled. Similarly, C2 square V2 square positive and here it is negative. It is also negative because this minus sign multiply inside, so these all terms become negative. So this value is also cancelled. Then we get C1 C2 V1 square C1 C2 V2 square and minus 2 C1 C2 V1 V2 upon 2 C1 plus C2. Okay, now student, we have C1 C2 common, therefore C1 C2 and inside we get V1 square plus V2 square minus 2 V1 V2 upon C1 plus C2, that is C1 C2 under root V1 minus V2 whole square upon 2 C1 plus C2. Therefore, energy loss in capacitor after redistribution of charge is C1 C2 V1 minus V2 whole square upon 2 C1 plus C2. This is the loss of energy of redistribution of charge in capacitor. So student, copy this. Today we are close to this topic. This is loss in energy, U initial minus U final in redistribution of charges. Thank you.